Hello and welcome to today's PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. Remember that you can ask questions anytime throughout the webinar, the presentation, and the Q&A, and you can do that by clicking chat near the top left of your screen and selecting everyone for the to field before you send off that question. And make sure you let us know where it's coming from, whether it's a particular student or the class, school, or city. Let us know something about where you're connecting from so that we can give you a shout out when we ask your question. Today's guest is Rachael L'Orsa. She is a PhD candidate in electrical engineering in Project neuroArm's Surgical Performance Lab at the University of Calgary. Thank you so much for joining us. I'll let you take it away.
Great. Good morning. Let me just pull up my slideshow here so that I can share it with you guys. Here we go. Okay. So yes, good morning. Thanks to Stacey and to Partners in Research for hosting me today, and thanks for all of you for tuning in. As Stacey mentioned, my name is Rachael, and I'm a student at the University of Calgary in Alberta. I'm a part of a team that's working on a really cool robot that does brain surgery, and I'm really excited to tell you all about it. This presentation is meant for students in kindergarten through grade 8, so before I tell you about my research and what we do in our lab, I'm going to tell you a couple of things that I wish someone had told me when I was your age. And then I'm going to talk about some of the basics of robotics so that my research makes sense. So, go on to the next page here. All right. So you might be wondering, because even a lot of adults still don't know, what exactly is a graduate student? So maybe it's the same where you're going to school, but where I grew up, we had elementary school, which is your kindergarten to grade 6. And then we had middle school, which is grades 7 and 8, and then high school, which is grades 9 to 12. So in elementary school, you learn the basics of a bunch of different things like science or math, reading, writing, music, all that kind of stuff. And in middle school, you start to learn the different parts of each of these areas, like maybe chemistry and physics and biology instead of just science. And then in high school, you learn even more advanced things in each of those areas. So it's the same if you decide to go to university, except you pick a general area to go into, like science or fine arts or business. Then, for your first 4 or so years of your undergraduate degree, which is kind of equivalent to like elementary school, you learn the basics of something that you love. And if you go back to school after that, you're called a graduate student, which is what I am. So first you do a master's degree where you pick one specific thing you want to study, like say robots that can help you around the house, and you learn as much as you can about house robots. And you do a research project that's kind of like a science fair project, but bigger on that specific thing. And if you still want to learn more, then you do a PhD, which stands for a Doctor of Philosophy, which is different from the medical doctor that you go to see when you're sick. And as Stacey said, I'm a new PhD student who's studying how to make special surgical robots even safer. I have to come up with something brand new that adds to what everybody else in my area has come up with. So right now, I'm like a researcher in training focused on robotics. Okay. So, you might be wondering why I have a slide about what is a robot. But what exactly is a robot? As soon as I say robot, you're probably thinking of something in your head already. You probably have an idea of what you think a robot is. Maybe you're thinking about Baymax from the movie Big Hero 6, or maybe you're thinking about one of NASA's Mars exploration rovers that are looking for traces of water and other interesting things on Mars. But experts still can't agree on what the definition of a robot is. Some people think that a robot is any kind of machine that can follow commands, whereas other people think that robots are machines that can do things on their own. So what do you think? Is your dishwasher a robot? Because that's a machine that can both follow commands like wash my dishes and do things on its own. So I'll let you decide what you think a robot is. But in the meantime, I'm going to tell you about two different kinds of robots. There are teleoperated robots and there are autonomous robots. So the word teleoperated is like telephone or telescope, where a telephone lets you talk to someone who is far away and a telescope lets you see things that are far away. A teleoperated robot lets you move it from far away. So you probably already call this remote control, and you've seen things like remote controlled cars or remote controlled drones like I have in this picture here. And even your TV is teleoperated if you use a remote control to turn it on. So on the other end of the spectrum are autonomous robots. And auto in autonomous is like autopilot, means that the robots can do things by themselves with few or no instructions from a human like you. So you can probably already think of a bunch of different things that people use robots for. If you've ever seen a Roomba, you know that robots can do the vacuuming for you. They can do all kinds of household chores that maybe you don't want to do for yourself, or maybe you don't have time to do for yourself. There are also a lot of fun robots that can teach you things or that you can drive around and have competitions with. Hopefully, you guys have heard of some of the robots that Canada has made to help astronauts, such as the Canadarm2, which is on the International Space Station right now. That robot helps astronauts do stuff out in the vacuum of space, which is a really dangerous place for human beings, of course. The Canadarm2 is teleoperated, just like I was just telling you about, so it can be controlled by a human who's somewhere safe. In the same way, other teleoperated robots are used to help with things like bomb diffusion or doing repairs in a nuclear reactor or doing search and rescue missions where maybe it's hard for humans to get. Now, if you were to look up manufacturing robots on YouTube, you'll find robots that do a lot of heavy lifting for us. So jobs like putting cars together are much easier for robots than for human beings because they're strong enough to throw an entire car around, and they can do it all day and not even get tired. Okay, now another kind of thing that you can use robots for are when you need a helping hand. So say you've gotten hurt. Maybe you hurt your leg and you're having a hard time getting better, or you're a grandma or grandpa who has had a stroke. There are robots that you can wear that can help you relearn how to move, or if you're paralyzed, might be able to help you walk again. These are called exoskeletons because they're like an extra skeleton that you wear on the outside of your body. Some people think these aren't robots, but again, that goes back to what you decide to call a robot. Now, robots can also help you with other things that are hard for humans to do, like microsurgery. For example, if there's a tumor in your brain, you want to be able to remove just the tumor and nothing else. So you need to be able to do tiny, tiny movements with your hands, but you don't hurt any healthy brain tissue while you're getting the tumor out. Surgeons can use a microscope to help them see all the small stuff, but a robot can help you do really small, precise movements that shouldn't normally be possible for human beings. All right. So, one of the first things people wonder about when they hear about robots poking around in your brain is it safe? And the answer is yes. There are a bunch of reasons why it makes sense to use a robot for surgery, and not just brain surgery, but any surgery. So there's something that's kind of new in surgery. It's been around for the last 15 years or so, called minimally invasive surgery. Back in the old days, if you got hurt, the surgeon would have to cut you open and get their hands in there and be able to take out what they needed to remove, or fix what they needed to fix. But the thing is, that takes a long time to heal because it's really hard on your body. So now we're trying to move towards something called minimally invasive, which means it doesn't hurt your body as much. So instead of cutting a big hole, you're cutting little holes inside the body and you're putting little tools in. So this makes it a lot easier for you to heal. So instead of taking 2 or 3 weeks to heal from it, maybe it'll only take you 2 or 3 days. And robots can help with this because they help you, you can have little tools on a robot and still move in those super small, superhuman movements without making it hard on the surgeon to do it while it's inside your body. Another reason why robots are really good for surgery is because they can get rid of the jitters. So when you're trying to do these super small little movements, if you've had coffee, or maybe you haven't had enough sleep, or maybe you're tired because you've been in the operating room for 9 hours or something like that, you can't help it as a normal human being. You're going to start getting a little bit of shakiness in your hands. And robots can help remove all of that so that there's no shakiness at all. Another reason they're good is because they work with image guidance systems. So if you've ever heard of X-rays or a CAT scan or an MRI, these are all ways that medical professionals help look inside your body to find out what's going on. Now, you might need it, so if you have something wrong with your bones, they're probably going to look inside your body with an X-ray to see if your bone is broken or if it's in the wrong place or something like that. But if you have things wrong with your soft tissues, like either your brain or your stomach, your kidneys, your lungs, something like that, they have to look inside with other tools. And when you use robots to do surgery, you can use these X-rays or these MRIs, these other tools, to help guide the robot as it moves inside your body. So this is all part of it being minimally invasive, where instead of having to cut a big hole to look inside and see what's going on, we just put tiny little tools in through little holes, and we can use these X-rays or these other imaging technologies to help the robot move around. Another reason why robots for surgery makes a lot of sense is because you can do it from anywhere. So when we talk about teleoperated, what it means, yes, you're doing it from a distance. So you could have the surgeon in one place and your patient in another. And in fact, they did gallbladder surgery back in, I think it was around 2002, between the United States and France, where the patient was in France and the surgeon was in the United States. So if you think about that, maybe you live in a really small town and you get hurt and you need access to the best surgeon in the world, but they don't have enough time to move you to wherever that surgeon is. So if we have one of these surgical robots in your town, then you can get access to that top-notch surgeon no matter where the surgeon is. So they can be operating that robot from a long ways away. Another thing that's really great about using robots for surgery is that they can be used to train new surgeons. So all of the information from expert surgeons can be saved and used to help new surgeons figure out how to do it properly. So moving on to kind of what I do. So as Stacey had mentioned, I am in one of the research labs for something called Project NeuroArm, which is a really, really, really cool project based in Calgary at the Foothills Hospital. So our robot does brain surgery, and it was made by the same people who built the Canadarm 2, which is pretty exciting. So it doesn't look the same as Canadarm 2, but it's similar in that it's also a teleoperated robot, so it's operated from afar. But in our case, instead of having astronauts operating the robot from inside the International Space Station, or maybe someone from ground control operating the robot, our surgeons are just in the next room to the robot, so they can see the robot, but they operate it from a different room where they can be comfortable, which is pretty important if it takes 9 hours to do your surgery. As we were talking about before, with the different imaging technologies that you can use to help see what's going on inside of your body, our robot works specifically with something called MRI, and that uses magnetic technologies to help see what's going on in things like the middle of your brain. Another thing that's really exciting about our robot is that it lets surgeons feel what the robot is feeling. So what that means is there are sensors on the tip of the robot that record how much pressure or force is being applied to the patient. And this information gets sent to the surgeon so that, as far as the surgeon's concerned, they're actually doing the surgery. So they can feel like they're touching you when they do surgery. And it's able to do really, really tiny, precise movements, so it does brain surgery. So it's a one-of-a-kind robot that doesn't exist anywhere else in the world, and it's here in Calgary being worked on by Canadians. So I'm going to shift a little bit to something that might seem a little unrelated at first, something called a neural network. And you may have heard stuff in the news about deep learning or artificial intelligence. Neural networks are something that's kind of used to do this type of thing, to make stuff smart. So maybe for the self-driving cars that are starting to come out now, they might use neural networks to help learn how to drive in different conditions. Like, because driving in a dry day is not the same as driving in a rainy day, and they have to learn how to manage those types of things. So neural networks are based on how the human brain works, and they're just kind of like a way of holding information and a way of looking through the information. It's kind of how humans learn, but this is specifically what I work on. So I'm working on using neural networks to teach robots how to be smarter. And more specifically, I'm doing that here at Project NeuroArm. So let's move on to something that I just wanted to quickly talk to you guys about in terms of research, because I know you're interested in research because you're watching this webcast, but maybe you don't know much about it and you're thinking that maybe it's only for brainiacs or only for a specific type of people. Well, I want to tell you that that's not the case. When I was your age, I had no idea what I wanted to do specifically. I didn't know that I wanted to be a researcher. I was interested in a lot of different things, like sports and being outdoors and math and science, and I was in French immersion. I really liked languages. So when I graduated from high school, I had no idea that I wanted to be a researcher. I spent some time working outdoors, mostly putting out forest fires. Then I knew that I liked medicine, so I got my paramedic license because I thought maybe I wanted to be a doctor, and I wanted to know what it looked like first. But then I went back to school and I studied a bunch of different things at the University of British Columbia. I studied mechanical engineering, which is kind of all about things that move. It's about machines and stuff that just moves in general, but especially robots, because I knew that's what I wanted to do. So I also really like languages, so at the same time I studied French and Spanish and computer science, which I took because I was kind of afraid of computer science. I didn't really understand how programming worked, and I thought, you know what, I'd better learn about this because it makes me a bit nervous. And I found out it's actually pretty exciting and fun, and it's just like learning a new language. So when I finished my undergraduate degree, I knew that I definitely wanted to do more with robots. So I came here to the University of Calgary and started studying electrical engineering, and especially how to control robots. Now, you might be wondering if you're interested in robots, how can you move towards something like this? How can you learn more about them? How can you put yourself on a path that might lead towards research someday, or it might lead towards building robots or something equally exciting someday? So my recommendation would be to join a robotics club. There's a bunch of different types of youth robotics programs in Canada. Two of the biggest ones are FIRST and VEX. You might even have one in your school. You should maybe try to find out about that. Another thing you can do is learn some programming. So some people don't like programming, but it's probably because they haven't learned from an awesome teacher yet. And programming can be super, super fun, and you'll find that it's extremely useful in just about everything you do. Another thing you can do is learn how to build things. Maybe your town has a makerspace, or maybe you have wood shop or metal shop or machine shop in your school. These are all fun things where you can do projects and learn skills one by one. And learn how to fix things when they're broken. Those kinds of things are going to really, really help you if you ever want to get into robotics. And you have to be sure, don't be afraid of failure, because if it seems like it's a little bit intimidating, it just means that you haven't had a chance to learn it in the right environment. So I wanted to thank you again for your attention. Hopefully I've given you a really brief introduction to robotics and what we're doing here with robots for brain surgery. And I'd like to hear from you guys what your questions are.
Well, we definitely have a few questions queued up here already, and I'm sure they'll start coming fast and furious now. If you want to go ahead and click the stop share button at the top, we'll be able to see a bit more of you, and then we'll answer these questions. So first, you actually already answered one of our questions. Ms. Suenda in North York, Ontario had asked if a child wants to be a robot builder, what are the subjects or areas of studies that they need to master in about grade 4 to grade 8? So we talked about learning to build things, we talked about computer programming. Are there any subjects in school that you find you lean on more?
Well, honestly, getting into robotics isn't so much about what you learn, because I think all of the skills can be picked up pretty easily if you are excited about it and want to learn it. What's more important is not being intimidated by it, because some people think that robots are super high technology and maybe it's a little intimidating to start learning about it. But I don't think there's any one subject in school that could help you with it. It's more having that open mindset to try things and try things and try things. Maybe it breaks 100 times, but on the 101st time, it works.
I hear that time and time again from all of the researchers we talk with, that most often whatever you're researching doesn't work and you keep changing things and eventually it works. So same with robotics. I want to move quickly through some of our questions here. There are so many. Ms. McCormick's class at the Clandonald School in Alberta, Trey actually in that class, wanted to know how are you able to communicate with robots remotely? For example, how do you tell a rover on the moon what to do?
That's a very good question. So one of the ways that, like, if you think about how cell phones work or how your wireless internet works, it's pretty similar in terms of how you communicate with robots. So like our robot here at the University of Calgary, we actually have a wired connection, which is kind of like old school internet, or if you have an Ethernet cable plugged into something. But if you want to talk to a robot that's on the moon, you're going to have to do some type of wireless communication. And obviously we can't put a cable from Earth to the moon. That's not going to work. So what we do is we have to send our signals through space. So you have to bounce them off of satellites and then either have a receiver station on the moon, something like a landing shuttle that can then communicate directly with a robot that's on the moon, or you have your robot set up so that it has a receiver and can receive those essentially wireless signals, those radio signals, directly from a satellite.
Excellent. We have another question here from Calgary, Alberta this time. It says, my grandpa is hoping to get robotic surgery on his cancer, but he's heard you need to have at least 200 successful robotic surgeries before someone is considered experienced enough. Is this true?
That's a good question, and I'll have to admit that my expertise is only on Project NeuroArm. So there are robots out there that do surgery in like your abdomen and stuff like that. Especially there's one called the Da Vinci robot, and there are hundreds, maybe thousands of them all over the world that do surgery. So I don't know exactly what the rules are for getting a surgeon trained on those robots. I know that our robot is currently getting approved by Health Canada. So it's in something called clinical trials, where you have to do, it's like the patient has to say, yes, I'm okay with trying out this experimental surgery. So it's possible that the surgeons for other kinds of robotic surgery have to do 200 trials to get trained up, but I know for sure that there are definitely Canadian surgeons who are trained up in robot surgery for other kinds of cancer removal. So hopefully your grandpa could find one of those surgeons and get into their surgeries.
Excellent. And I want to move on to a question from Andreas in Belleville, Ontario, who wants to know, how long has it taken to develop this technology, so the neuroArm robot?
That's a very good question as well. And it kind of depends on where you pick the starting date. Because this kind of, like the idea of robots for brain surgery has been around for a really long time. I want to say since about the 80s, so since 1980. Where they were just using robots to position tools as accurately as possible. But so one of my supervisors here, Dr. Garnett Sutherland, who's a Canadian neurosurgeon, he had the idea. Actually, it's a good question. I don't know when he had the idea. Sometime in the early 2000s, he decided, you know what? There's got to be a better way of doing this surgery. We've got to be able to do better surgery on patients. And it took several years just to get the business up in terms of how do you find all the engineers and how do you get approval to build this and how do you get the money to build this. And the first surgery was in around 2009, I think. So probably, it's hard to say where you count it from. Because robotic technology has been improving for decades, but for Project NeuroArm itself, I think it only took around 5 or 6 years all told to develop the actual robot, but it's still in development now. That's why I get to be a student here, so that we can keep making it better and better.
And that's amazing, but there must be a large team. We're not talking 5 years of one person. How many people have been working on this project?
That is also a good question, and it depends on how you count it, because as I mentioned, the company that built the Canadarm 1 and 2, McDonald Detweiler Associates, which is a Canadian company, they built the original version of neuroArm, our robot. And I'm not entirely sure how many of their engineers were working together on getting it designed and getting it made, but it would have been a substantial team. I know that here in Calgary, we've had anywhere from 10 to 25 people working on it at a time, and that could be health professionals like nurses and imaging technologists who are helping give feedback on how it works with other things. That could be the surgeons themselves, it's engineers, it's computer scientists who are helping with the programming, it's business managers who help get funding and help the group run properly, and administrators. It's all kinds of people.
That sounds like a very large and comprehensive team. I just want to shift gears a little bit. You talked a bit about autonomous robots, and I have a question here from Mrs. Zorzetto's class in Hamilton, Ontario. This is the grade 2-3s that are joining us. And Ivy asks, how might you make a robot that can think for herself?
Ooh, Ivy, that's a very good question. And I just briefly talked about it. I mentioned something called neural networks, which are kind of like electronic brains, and they hold information and they can learn things over time. We have to teach them what they're supposed to learn, but if you had a robot that you had made one or many maybe of these neural networks for, so kind of like a robot brain, and then you trained it, then it could start thinking for itself. If you've ever heard of the Now robot, you can look that up on Google or on YouTube. It's NAO, Now. Apparently, these robots are even self-aware. So they've spent a lot of time programming them to make them able to learn, and they're able to think for themselves.
That's amazing. So we also have a question from Mrs. Hurst's class in Brantford that's sort of along the same lines. How close are we to autonomous robots that have artificial intelligence and can make their own decisions? So to some extent, we're there already?
Yes, absolutely. And it kind of depends on what you consider autonomous, because there's a range of autonomy as well. So if you think about your dishwasher, so all you have to do is push the button that says heavy cleaning cycle, and it knows what to do. So it does that heavy cleaning cycle autonomously because somebody has programmed it to say, okay, heavy means it's really dirty, so we've got to do extra long cleaning on this. But in terms of having a robot that is completely intelligent like a human being, we're still quite a ways off from that. So as I mentioned, the now robots supposedly can think for themselves. They can figure things out like maybe a 5 or 6 year old human could. But in terms of having a robot that has all of the intelligence of an adult human, we're quite a ways off still. So there's plenty of room for you guys to help us with that.
There we go. So just to expand that, if you had to take a guess, we've got Leo in grade 4 from Ms. Goulet's class was asking if you think robots will be able to operate without human direction, and if so, how soon? So maybe something like the surgical robots as an example.
Yeah, that is another really good question. You guys are full of great questions. So that is the eventual plan. We don't want to force surgeons out of work, but if we can make robots that can do surgery better than a human surgeon, then we want to have the surgeons be able to oversee the robots so they can say, oh yes, what you're doing is correct. But we want the robots to be doing all the hard, finicky business that's maybe too small or too delicate for a human to do properly. So there are robots that can do portions of things all by themselves right now, portions of things autonomously. So I mentioned that robots for brain surgery have been around since about the 1980s. And what they do is they can position themselves autonomously. They can look at, like with the help of a human, they can look at, okay, well, the tumor is somewhere deep in here, so I need to position myself over here so that I don't hurt anything on the way to that tumor. So right now, robots can do that. They can figure out what the best positioning and angle and entry speed is and stuff like that. But we still need humans to oversee that because we want to make sure that it's really, really, really safe. Eventually, we want to get robots doing surgery completely, but it's a pretty tough problem because if you think about it, everything in your body is squishy. If everything was hard, then we would know, we would take one x-ray or one image of your body and say, okay, that thing that we want to work on is right here. So my robot knows exactly where it needs to go. But because everything's squishy, maybe when you put your tool in, everything moves. And now if the robot's going to do that all by itself, it needs to be smart enough to figure out, okay, everything moved. So if I want to get to that kidney, now I have to go over here and around there. And yeah, so there's a lot that's going to have to go into these robots to make them smarter and smarter until they can do surgery autonomously. If I had to guess, I'm going to say maybe 20 years. That's a really rough guess.
It's so hard to guess, but I appreciate you trying. So lots of time for all the students watching today to be part of this solution if you're interested in surgical robotics. So we've already gone over time. We had so many great questions. I was trying to squeeze them in. Thank you for staying with us, Rachel. I've got one more for you to cap off. We've got students at Dr. G.J. McGilvery Public School in Curtis, Ontario, who want to know what would you suggest as a starting point with robotics for elementary students?
Ooh, that's a very good question too. So I'm actually involved. I mentioned earlier First Robotics and X Robotics as two youth robotics programs that are done a lot in Canada, and I'm quite involved with First Robotics. Both at the 9 to 14-year-old range, which is First Lego League, and also at the high school range, which is First Robotics Competition. So because I'm really familiar with that, I want to recommend it because I know that it can be a ton of fun. So in that age range, there's Junior First Lego League where you start to learn about robotics and learn about coming up with ideas by yourself, and then there's the First Lego League for 9 to 14-year-olds, and then gets more and more and more advanced. So that would be my recommendation just because I know it. But even just, there's so many different kinds of fun learning robots that are out there that are going to teach you how to program and basic concepts of robotics. So even just searching on Google would probably come up with some cost-efficient and really fun different robots that you could use.
Awesome. Well, that's all the time we have. Thank you so much, Rachel, for joining us and answering our questions and staying late to answer more questions. We've really appreciated your expertise today.
Thanks for tuning in.
So we have 2 webinars next week on PIR Live event. First, we're talking about urban air quality and sustainable transportation, and then we learn what goes on behind the scenes at the Canada Science and Technology Museum. So more information on these and more upcoming PIR Live event webinars is available at pirweb.org. Thanks for tuning in, everybody. Have a great day.